So, welcome back everyone. This is Jan-Piet. He calls himself the old fart on the internet. Is that right? Sometimes, okay. He brought some nice Lego and embedded electronics and will tell us how to monitor small electronic things. Give him a warm welcome.
Thank you very much. My name is Jan-Piet. Welcome. I've called this talk something with monitoring because this is a monitoring conference, so you need a good excuse to be here. But we're not. Well, we're also going to talk about monitoring, but sort of as an aside. What we're going to talk, or what I would like to tell you about a little bit today is a short recap of MQTT. Some of you know what it is already, but we'll just go through it relatively quickly for a particular reason. And I want to talk about ESP8266, which is a small microprocessor. And I've brought one along, and this is one model, and I'm going to give it around to you, perhaps hand it from person to person. You can have a look at it. I want it back, okay? So I expect it in the front row at the end of this. I'll be handing quite a bit of stuff around, so I want it all back. I've got an inventory, okay? So I'll be telling you a bit more about this, but it's going to take a while. That's why I'm giving it to you now already. So what we want to do is to couple these things with MQTT, the MQTT protocol for doing monitoring, and I'll explain why in a moment. Now, MQTT, first of all, is a standard. Sorry, I'm already now losing my headset. It's a standard, it's a transport, it's a publish-subscribe protocol, which was originally designed for unreliable networks with high latency, low bandwidth. Now, if you consider any smartphone, for example, that you have in your pocket, whatever the make or brand, this is the epitome of unreliable, okay? We have Wi-Fi in this room, we go to the next room, we have a different Wi-Fi, we have 4G, we have 3G, then there's this edge thing, which means offline, that's where the E shows up in your display, and then you go back to Wi-Fi, etc. MQTT is ideally suited for this kind of network. MQTT has up to 256 megabytes of payload. This, for a number of use cases, is of course purely theoretical. That little microprocessor that's going around now has, if I remember correctly, 4 kilobytes of RAM or 64 kilobytes of RAM. Nobody is ever going to be able to manage a 256 megabyte payload on a thing like that. But the protocol allows it. And MQTT is fast. MQTT has a number of built-in security measures. In principle, these are transport layer security, TLS. Then, of course, authentication. A client can authenticate towards a server and say, I am this client, please allow me to do something. We'll talk a little bit more about this. Then we have access control lists in MQTT on the server side. And these access control lists allow or disallow particular operations. In other words, will allow a particular client to do a publish and or a particular client to do a subscribe onto messages that it's interested in. Of course, at any point in time, you can additionally or exclusively encrypt your payload. Here again, very strongly dependent on the kind of device you're using. A little microprocessor like the thing that's going around on Arduino is just not capable of doing, or basically not capable of doing encryption because it just doesn't have the CPU. But of course, MQTT on a Mac or on your workstation, etc., is certainly would be able to do it. And there's something quite interesting called TLS PSK, which is available in certain implementations, and that is TLS with a pre-shared key. This allows us to do transport layer security without having the hassle of certificates which expire, etc. MQTT has 3 different so-called levels with which it can transport a message. These levels are called quality of service, QoS, and they are numbered 0, 1, and 2. And the little yellow arrows on the right-hand side of the slide show you basically how much communication occurs. So quality of service 0, QoS 0, means at most once, and this is basically like a UDP datagram, although MQTT runs over TCP. Like a UDP datagram, it's sort of fire and forget. We fire it off and we hope that it gets there. It typically does get there, but it might not get there. I forgot to mention something very important. this is a bottle of white chocolate sauce, chocolat blanc. And it's made by a company called 1883. And I chose this because 1883 is the TCP port number which is reserved for MQTT. Don't worry, if you ever hear another MQTT talk of mine, you'll see a different bottle. They make all sorts of different things. So, at most once, quality of service 0, assured delivery, QoS 1. That means that a message is published and it is guaranteed that it will arrive. It could, though, arrive more than once. And QoS 2 is once only. There, the protocol describes that the interaction between client and server is such that a message published by a client will arrive exactly once at a server. Messages in MQTT are addressed by so-called topic names, topic branches. A topic name has a limitation of 64 kilobyte UTF-8, which ought to be more than enough in terms of length. Topic names are hierarchical, and they allow, on the subscribing end, they allow us to use wildcards. So assume we have, for example, a small temperature sensor, which publishes to a topic called temperature/room/living. That would be a fully qualified topic name. And we can have a subscriber which is interested in all topics, all messages that come to the topic finance/plus. This stands for one level /euro/rate. So this would hit, for example, finance, yahoo.euro rate finance, whatever, msft.euro.rate, etc. And we have the wildcard hash symbol, which is a little bit like the asterisk in a shell, in a Unix shell, which means any amount of topic branches after this at any length, any depth. So anything, devices /temperature/sim, anything below that level. Messages are coupled loosely, or clients and servers are loosely coupled to each other by being able to publish into what I like to think of as a large cauldron, a large boiling pot, where we have publishers dropping in messages over MQTT on particular topics, and we have, on the other hand, we have subscribers picking them out. And this cauldron, this bus, this huge pot allows us to, for example, very, very easily, with basically very frequently very few lines of code, I'll show you a few in a moment, for example, pick out messages if we're allowed to do so, if we have authorization to do so, pick out messages, transform them, and drop them back in for a different subscriber. So assume we have, for example, our ubiquitous temperature sensor, which we bought in the United States, and it's idiotically, it is publishing in Fahrenheit. Nobody in the rest of the world gives a damn about Fahrenheit, and I certainly don't. So we would have the temperature sensor publishing Fahrenheit payloads into this cauldron, and we can very easily create a subscriber which picks out this topic, picks out the payloads with the Fahrenheit, converts to Celsius, and dumps them back in for other subscribers to pick up. Loosely coupled means that at any moment, this server, this cauldron, at any moment, this MQTT server can have any number of publishers, can have any number of subscribers, and these two, publishers and subscribers, are loosely coupled. A message is transferred if there is a publisher publishing on a particular topic, and simultaneously a subscriber subscribed to that particular topic. If there is no subscriber, then a publisher is a little bit like going into the woods, deep into the woods, and yelling. Nobody hears you. Okay? If nobody's there, nobody can hear you. One important thing is called a last will and testament. It's a special type of message. A client that is going to connect to an MQTT server, the server is called a broker, so I'm going to use that word from now on. A client that is going to connect to an MQTT broker can tell this broker, in the case of my demise, in the case I die, for example, power cut, my application crashes, whatever, in the case you don't hear from me in a particular time frame, please publish this to any subscriber of this particular topic on my behalf. So a client connects to a broker, sends off a last will and testament, and if that client dies for whichever reason, network, power, any reason, the broker will then, on its behalf, publish the fact that this client has died. Monitoring. Okay? Monitoring. You can very, very easily, for example, monitor MQTT clients that have just gone away. Okay, broker. We have this term. I'm going a little bit faster. We have the term broker. This is the sort of, if you like, the server side of MQTT, and a broker is a little bit. I think of it a little bit not only as a cauldron, but as a sort of bus, as a sort of message bus. And there are a number of brokers. One very popular open source broker was created by a man called Roger Light, and it's called Mosquito. It's called Mosquito with a double T, which is actually a spelling mistake, but I believe Roger was looking through a dictionary, looking for words that contained MQT, and he didn't find any, so created Mosquito. Okay, it's a program which is written in C. It's available for all distributions. It is tiny, very lightweight. It supports almost everything that has ever been published in the MQTT protocol. MQTT has been standardized. It's not an RFC though. I'm forestalling Stefan Berzemeyer, who's going to ask what's the RFC number. It's not an RFC. Mosquito supports WebSockets, it supports TLS, it supports access control lists also with plugins, supports TLS PSK, which is excellent, bridging, I'll talk about it in a second, and it's of course open source. There are a number of other brokers, for example, VernMQ, which is written in Erlang, very powerful, HiveMQ, which is written in Java, which also, for example, supports clustering and things like that. So it's worth looking at different products. If you're into Node.js, there's one which was created called Mosca, which has a number of backends, quite interesting. But Mosquito is a really small, capable broker, and this small, capable broker runs on equipment even this size or smaller. I'm going to pass this around. This is my newest love. It's a GL iNet AR150. I'll talk about this in a second. It's so sweet. Anyway. It is. Wait till you hold it in your hand. But that I really want back. Although it's not really very expensive. It costs 22 euro or something. So, spoke about bridging. Bridging is the possibility to couple two brokers in such a way that messages, for example, from this publisher, which actually go to this broker, will in addition be, let's say, mirrored or translated over to a second broker, for example, in a second data center or in a friend's house or whatever. But not all messages that arrive at this broker, but just those. And these messages can then be coupled by these two brokers. Here again, quality of service. We can define appropriate quality of services to ensure that these messages actually arrive at the second broker. The advantage also of doing something like this in terms of firewall, we can decide whether this broker will initiate the connection or whether the second broker will initiate the connection, which is of course important for firewalls. Two command line utilities, Mosquito sub, which I'll show you in a second, Mosquito sub, Mosquito_pub, subscribe and publish. They have a daunting number of options, but the only ones that are sort of really interesting are those that I've shown here. We specify which topic we want to subscribe to with -T, and then of course with the appropriate topic, here with a wildcard, and Mosquito pub, we specify a topic and a payload. And optionally a retained flag. This is another feature of MQTT. We can publish a message with a retained flag, and this is an indication to the broker, would you please store this message? When a client then initially connects to this broker and subscribes to this particular topic, the broker will immediately send out this last known good value, this last known retained message. Okay? MQTT is available in, I think, any language. The only language that occurs to me that doesn't have MQTT support is COBOL, but I think the rest all have it. And of course, Lua, Python, C, JavaScript, Java, anything. Yeah? And just two short examples in Python, because it's a relatively readable language. I hope you can sort of follow along. We have an import statement. This is Power MQTT library published by Eclipse, actually originally also written by Roger Light, who created Mosquito. And then we have an MQTT single, which is a function which publishes a payload on a particular topic. Had I had a subscription running for this particular topic, I would then see this payload. Okay, here's this minus v shows me the topic name, and this is just the payload that we see here. On the other hand, Python can also, of course, subscribe, and this is a little bit more work because with subscriptions, we can have messages sort of arriving in the background. What we do is we set up callbacks and then perform a connect, and for example, going into an endless loop. And this endless loop will fire our on-message callback as soon as a message arrives to which we have subscribed. And then this message will simply be printed out. Just a small trivial example to show here. This would be our typical little program which subscribes to the Fahrenheit sensor and translates that into... Sorry, I'm very unhappy with my ears. Well, actually, I wasn't until I had this thing put on. Right. Yeah, thank you, Marcus. I'll carry on anyway. Would we run our subscriber at the bottom? Thank you. Would we run our subscriber as here at the bottom of the page and then publish to conf/thirsty and conf/catering? Recall, I'm going back here. We subscribe to conf/plus, so one level. Then we would get the appropriate payloads shown us. If you have any questions, please shout in between, okay? Right. So that's just sort of a little bit of basics of MQTT, and the reason I'm telling you this is that let's look at a little bit of hardware, and this hardware will use MQTT for communication. So who's got my little router? Where is it? Oh, it's only there. Oh, you, okay, carry on. So what you're seeing there is a little router called a GL iNet AR150. It costs the unbelievable amount of €22.83 at Amazon.de, including free postage, of course. This is just, to my mind, is mind-boggling, but anyway. It runs OpenWRT. It runs a Linux distribution, OpenWRT. You might know OpenWRT from the TP-linked MR3020, which is used as RIPE Atlas probes. Stefan, who's sitting here, will be telling us a little bit about those tomorrow, or the use of those tomorrow. And so this is very similar in hardware. It has a little bit more RAM and it has a little bit more flash. Flash is what we need on the file system. It has two USB ports, a LAN and a WAN port, and built-in Wi-Fi. Now, one of those things that you see there, I have here in light blue. Pardon my fumbling here around. I have here in light blue. This is basically exactly the same thing. It just has a little bit more RAM. Not that I need it. It's just I had this one before I ordered those. Okay. So this thing here is now just simply powered by USB, and it provides a Wi-Fi network. And this Wi-Fi network provides the network for this thing. Now this thing is a ESP8266 Wemos D1, which you've already seen, connected to an LCD panel or liquid whatever seven-segment display panel. Now while I'm talking, I'll hand you. We can carry on. I'll hand you another of these things. Now this looks as though there's a lot on it. There is a lot on it. There's just little boards soldered on to hold it. And at the top, there's a button. Okay? So every one of you press the button, please. And as soon as you press the button, sorry, I forgot to mention, this is, of course, also connected to this Wi-Fi. And it's going to, when you press the button, it's going to send off an MQTT message. And I've lost my track. It's going to send off an MQTT message, and if you've successfully pressed the button, that display will change. Okay? Now, please only press it once. If you press it twice, you buy me a gin tonic. Okay? That's the deal I made with my daughter. So you go ahead. You press it once. If you have rings on your fingers, would you please be a little bit careful not to short it, otherwise my demo is immediately over. Yeah? Be careful, please, that you don't short it. So he's pressed it once, goes to 2. You press it once, please, goes to 3. You press it once, goes to 4. Ha! 6. We developed this at home. I had my Lego assistant build this, and to make it interesting, I said, "Well, let's build this gin tonic thing in. Don't be afraid. It's now. It was supposed to be just one, but I didn't know how many people were coming, so now we do it modulo 5. Yeah, you had a question?
Yeah, the question was that actually built in that makes somebody call for it.
I'm sorry. Could you repeat that?
The question was whether there was a built-in automatic sending thing of West.
There is. I'm expecting 25 gin tonics by lunchtime. Okay. So we have, on the one hand, sort of a little server, this little router, this little Linux box, which runs an MQTT broker. And on the other hand, we have here a system. I'll show you in a moment what's happening in the background, but let's just continue. We have little devices which can speak MQTT over the wire or over wireless. Now, one such example is an Intel Edison, for example. Intel Edison, this chip that you see, this is terrible. This chip that you see on the top right here is about the size of a small postage stamp. And this thing has somewhere around 4 megabytes of RAM. It runs a full Linux machine in it, and it is also, in addition, Arduino. It has an Arduino bridge. Now, I don't know about you, but this here, down here, is a 74, I think it was 74 pins. My fingers are not what they used to be, and I certainly wouldn't be able to solder anything on there. So with Intel Edison, you can buy you can buy boards where you plug in this Edison, and then you have sort of breakout boards. But this is not the kind of thing that you install in every temperature sensor, 10 per room, if you look at the price tag. We're talking about somewhere around the order of, let's say, 70 to 90 euro, which is quite expensive. Quite aside from the fact that you have here relatively high power consumption. But this is a gorgeous little thing if you don't know it. So one thing that is very interesting is, for example, Arduino. Who has heard of Arduino? Okay, many people, most of you actually. Which was to be expected. Arduino was absolutely grand and still is absolutely grand. Arduino, though, certainly the first models, had one deficiency. It was very difficult to communicate with the outside world from this Arduino, except via serial. And then came the Arduino with an Ethernet shield, and then came Wi-Fi shield, and then came Arduino Yun. Anybody know Arduino Yun? That's the one with a Linux computer on board. Also, OpenWRT cost somewhere around 70 euro. I thought it was very, very disappointing, actually, because it was quite expensive and the communication wasn't very nice. And then came a Chinese manufacturer called Espressif, and they created something called an ESP8266. That's the actual chip. And this is a low-cost microcontroller which runs a full TCP/IP stack. All of us know what that means. So it's a little bit like an Arduino. It can be programmed like an Arduino, although it can also be programmed, if you prefer, in BASIC. It can also be programmed in Lua, if you prefer the Lua interpreters for ESP8266. If I remember correctly, there's a MicroPython for ESP8266. So quite a number of different platforms, depending on your taste and depending on your preference. Now, what makes this ESP8266 absolutely incredible, I almost never use the A word. What makes it really amazing, that's another A word, is the fact that it has onboard Wi-Fi. And this amazingness, I will show you in a moment what this all costs, is really quite interesting because it's very, very inexpensive. And the ESP8266 comes in a number of different form factors. Now, we have here 3, 4, 3 photos of different ESP8266 models. This is sort of the first chip that came out today. You can get these for €1.50. don't, because it's just not worth it. This is the ESP12, I think it's called a 12F now. You see it's a little bit different form factor. You will probably recognize this as being the thing that is going around or that you saw this morning, okay? That you saw earlier. This is what it's called a Node MCU. It costs about €2.60. First class registered mail from China, obviously. A Node MCU, which has quite a number of I/O pins. It has a USB connector for power and also for communication. It has reset buttons and so on. And here again, you recognize sort of this thing here on top. That is the actual ESP8266 chip. This costs about €2.60. Okay. Now period. Now this ESP8266 really, over the course of the last year and a half, has totally swamped the world. Everybody's using them because they are so cheap. Just look at these prices. Now here again, here we have for €1.50, we have an 8266 with tiny little connectors. And this Wemos D1, which I'll show you in a moment, which you saw this morning, just has sort of broken them out a little bit more to make it more comfortable. This here, what I'm going to show you now, is an Electrodragon board, which costs €5.50, here again, including postage. It comes with a cover, it comes with a case. I only brought the bottom part. So what you're going to see now is this thing here. Comes with a cover, and you can connect 220 volts to it, and out come over 2 relays to different channels. So you can connect, for example, two clients, 2 lamps, 2 motors, 2 washing machines, whatever you like. In theory, I think this thing here does 10 ampere. If you show this to the German TÜV, they would probably get instant heart attacks. But it works, and our house is still, well, was yesterday when I left, still okay. Hadn't burned down yet. Haven't heard anything though this morning. Right, so really very interesting, and that also contains this ESP8266, which we can program, okay? This thing comes from China with an onboard software, with an iPhone and Android app, which of course phones home, no? Obviously, goes to some Chinese cloud. Now, I don't want Chinese cloud, so we would reflash that with our software, and I'll show you how in a moment. Another very popular thing, which is a little bit cheaper at the moment, is Sonoff. This only has one output. Here again, also 10 ampere, same kind of thing. On the additional, it has a little switch here, which is quite interesting. You can plug your load in and out manually. So the Wemos D1, is that switch still going somewhere? Let's just let me show you, please. Let me try and show you. Who's got the switch at the moment? Who's got the little button? Okay. Would you not flick it? Just keep it in your hand. Don't click it, please, yet. Now, what we're seeing here are MQTT messages. Sorry, let me redo that so you see what I'm doing. So I'm using Mosquito Sub connecting to a host called .8.1. That is a little GL-INET router, and I'm going to subscribe to all topics. Would you please, at the moment, not click? Now, interestingly, when I subscribe, I immediately, well, not swamped, but I immediately get a certain amount of topics. And these topics that I see, for example, sorry, escape sequences now come out because I'm pressing the laser, okay? These topics that I see are called sensors, home, and then they have a certain number, and then, for example, $online true, and they have a name and a local IP address. This IP address, by the way, .8.151, is the IP address of that Wemos D1 button that you're pressing, or that you're going to press in a moment. It has a firmware, it has a Wi-Fi signal, 68%, and it's showing me that open true. Now, these messages came from the broker. I subscribed to the broker, all topics, and these messages came from the broker immediately. The reason the broker had those retained, the client, which is running on that button, had said, when it was published, would you please retain those messages? Now, just pressing enter to, hang on, press enter again to show you. Now, would you please, whoever's holding it, once click and let go? Now, the button when it's pressed, it publishes a. Can you still hear me? The button, when it's pressed, publishes to a topic called button open with a payload false, and when the button is released, it republishes to a topic called itself button open with a payload true. Okay, because it's open. So if you click this now, please, a couple times, click, click, carry on. It won't cost you gin tonics now, we're in demo mode. Yeah, you see how this is happening. Now, let's do one more thing. Who's got the button now? Okay, would you please pull the plug? Careful with the plug. I mean, remove it from power, okay? Now, that client is going to die because it's powerless. Wie viel Zeit habe ich noch? Danke. Have you pulled the plug? Thank you. Zack. This message, device ID, online, false. This message was obviously not, I repeat, not published by the device, because without power, yeah, it doesn't have a battery on board. This is a last will and testament that the client originally published. That the client originally said when it originally connected to the broker, it said, if I die, yeah, if my friend pulls the plug, would you please on my behalf transmit this message to any subscriber? So, for example, our Isinga monitoring system could now immediately pick this up and say, oh, our sensor in so-and-so has died. Yeah? Somebody has to go and have a look at it. Now, do not plug it in yet, please. Let me now show you the reason for retained messages. I am now once again going to subscribe to the broker. So I'm a new client, I'm a completely new client, and I subscribe to the broker, and I get the retained messages from the broker. And these retained messages, just a second, these retained messages show me the last retained publishers. And one of the last retained publishers was that our device, $online, is false. Okay? Yes?
Yeah, and if you have many different devices connected to this broker, then you would get all of these retained messages from all of these if you subscribe to the wildcard.
If I subscribe to the wildcard, yes. So depending on how we want devices to communicate with me, with our client, we would subscribe either all. For example, a monitoring system would probably subscribe to sensors, sensors, homie, plus $online, yeah, and then it would get just the online messages. Here again, depending on whether the client is actually allowed to see those messages, we have to also see what the broker access control lists allow us to see. Yeah? But if we subscribe to a wildcard, then we will see everything that we are allowed or permitted to see. Correct. Oh, electric. Would you please kindly plug it in again? And we will see when the device goes online, one of the first things that it'll do, it'll publish information about itself, and will also probably, or hopefully anyway, say, yeah, okay, I'm online. Yeah, online true, I have this IP address, I have this firewall, this signal, etc. I'll tell you where this comes from in a moment. And we see button is open. Now please carry on, hand it over, and people can continue clicking. Okay, it clicks. So this little device that is clicked now is this Wemos D1 Mini, as it is called. It costs really very few euro, it costs €4. It has 4 megabytes of flash, 64 kilobytes of RAM. It runs on 3.3 volt. Careful, if you're an Arduino fan, you're probably used to 5 volt. This will fritz this thing. Marcus, I need your help. It's not the first time I've worn one of these. Thank you. It has 11 digital I/Os. It has 1 analog I/O, and it comes like this in a package with little headers, which you can solder on It's a really nice package. And this is this ESP8266. The nice thing about this Wemos, first of all, it's very small and relatively inexpensive, but so are the others. And the other nice thing is if you're not like if you're not particularly into soldering stuff, they also have a bunch of so-called shields. So for example, there's a relay shield where you can switch 220 volts with this. If you do, please be careful, that's 220 volts, okay? They also have an OLED shield, which is a little display, which is, yeah, very disappointing actually. They have a temperature sensor. This is tiny, no? This is, I don't know, half a square centimeter or something. It's tiny. They have a temperature sensor shield. They have, for example, an SD card shield. SD card shield? Do we really need that? Yeah, you could, for example, take the Wemos, build a little contraption that, for example, collects GPS data, and you write it into the SD card shield. Okay. So there's just certain examples of these little devices in the different packagings they come in, and the different qualities or the different capabilities they have. And one bit of software that I would really, if you are interested in this, and I would highly recommend, it's really good fun. One piece of software that I would highly recommend is called Homie ESP8266. It was originally written and still is maintained, very intensively maintained by a French chap called Marvin Roger, who's a student, and he's created an absolutely, yeah, gorgeous bit of kit, a bit of software. And this here, with just a little bit missing here, this here is the full software of the code running on that button that you're pressing now. Okay, so this framework, which also runs on Arduino, but it's mainly for ESP8266, provides this whole thing with retained messages, reconnection to Wi-Fi automatically, yeah, dollar online, showing signal, etc. Okay. How does one program these ESP8266? If you're interested in C, then you would, for example, use the Arduino IDE. Some of you will recognize this. This is a green Arduino IDE, which you've probably seen if you've done Arduino work. It's the same language. It's the same C/C++ language. You can also use something which I've only very recently discovered, which is called Platform I/O, which allows you to use VI or Emacs, and then from the command line, flash your devices. Also very, very nice. But if you're comfortable with the Arduino IDE, then this is something that is certainly worth looking at. And once again, just to show you the messages that are being emitted by these little devices, by this Homie. This Homie framework has this convention that it has so-called nodes, sort of with capabilities, which have a name. You can specify anything, for example, temperature sensor or movement sensor in master bedroom or whatever. Local IP, the firmware name, firmware version, Wi-Fi signal, etc., etc., etc. Okay, and because this was so great, we created something that we call homie-ota, because because ESP8266, these little $2 things, have the capability of doing over-the-air updates. Over-the-air updates means you've created a little device, you've created a little sensor, a little something, and you've installed it behind the paneling in your living room, and it dies. Or you decide to, not it dies, sorry, you decide to add something to the firmware, to add something to the software. That means, because you found a bug, that means you have to go, get them all out, unscrew them, get them all out, bring them back to your desk, and reflash them. With over-the-air updates, you are able to do this over the air, over the Wi-Fi, okay? And the Homie framework uses this capability that is built into the ESP8266 to reflash itself over the air. And because we were so convinced of this, we created homie-ota, which is a small Python package, or program which does this, okay? So you can upload firmwares and schedule updates, etc. Now, what is probably horrendous for you, but look at me, I mean, I'm not the youngest anymore, is the retro vintage style optic of this. It's just gorgeous. Okay? Right. So, what can you do with all this? We can do a whole bunch of monitoring. We can use these devices, these small devices, for monitoring. For example, yeah, your typical temperature monitoring, movement monitoring with a PIR a sensor, who's entered your data center, for example. Okay, you can have, or you can use inexpensive. Don't go too cheap, because cheap is not always nice. Inexpensive sensors. There are tons and tons and tons of examples that you can look at. Monitoring is interesting because of the last will and testament. Official hate for this thing now. Thank you. As I say, it's not the first time I wear them, but my head has changed. Because of the last will and testament, thank you, Marcus, which allows us to catch dead devices and alert of these dead devices and do things with it. Another thing that I would like to warmly recommend is either Node-RED, which was created by a couple gentlemen at IBM, very nice platform for integration with MQTT and other things, or MQTT Warn. MQTT Warn was created by myself together with Ben. MQTT Warn is a Python system which subscribes to any number of topics and has a whole bunch of plugins. At the moment, I think there are 50, which can then where you couple a particular topic and, of course, its payload to an alerting system, pushover or Twitter or SMTP or NNTP or whatever you like. Okay. So, and in terms of practical solutions, MQTT has been in use now for quite a number of years for all sorts of things. As I say, alerting, metering, logging. For example, there's a pipeline with something around 30,000, an oil pipeline which is being monitored with 30,000 sensors on it. Location awareness tracking, for example, our very own OwnTracks project does that. It's an open source tracking project. Automation, of course, home automation. Is James here? Yes. James, do you use MQTT at home?
Oh, yeah.
Yeah? Very good. For controlling, for monitoring, as we've discussed already. And so there's MQTT and all sorts of things. Greylog, for example, is an MQTT plugin where you can pump messages directly into Greylog. Ansible has, the Ansible configuration management system has MQTT alerters to, for example, indicate that something's happened or a playbook has finished. Guess who wrote that? RabbitMQ, the AMQP server software, has an MQTT plugin. CollectD speaks MQTT. OpenHAB, the home automation broker, is very, very strong in MQTT to talk to other devices that you may have in your environment. GitHub uses MQTT. Anybody know where? I forget what it's called. In GitHub, you can set up your GitHub account or a GitHub repository to issue, for example, webhooks or issue mails when a particular event occurs. For example, a commit arrives, and there's a whole number of integrations there on the right-hand side. I forget what this chapter is called. In there is also MQTT publish. Okay. Wireshark has support for MQTT. Fluxo are electricity meters, or Remake Electric. They make also electricity metering systems. It's a Swedish firm, very, very strong with MQTT, also on OpenWRT devices. Jenkins has support for MQTT, etc., etc., etc. There's a whole plethora of systems that have support for MQTT and use MQTT. And a good starting point for all things MQTT is mqtt.org, with a whole number of links and etc. Right. So, much earlier than expected. Any questions? Yes?
The homie platform, usually you have the sensors. Sorry. The homie platform, you can connect the sensors like temperature and stuff like that. So it does MQTT publishing to the broker, but can it also work the other way? Like you can, it can subscribe to certain messages and then like I don't know, switch something on or something
Absolutely.
like that? Okay.
Sorry, absolutely. Very good question, and I forgot to mention that earlier. This, if you look at this later on, in there you will see a Wemos D1 Mini with an ESP8266 that is also running Homie. Okay, so that is also a client that's running Homie, and it's subscribed to a particular topic, and that is what then flicks the LED. Yeah. Yes, of course, it can subscribe. Yeah.
The network you use for the demo is not the same as our network. It's a different Wi-Fi network, because I was trying to connect to the broker, but failed.
No, it's a private Wi-Fi. It's a private Wi-Fi. It's the SSID is JPM300A or something like that. Demos are bad enough because all sorts of crap can go wrong. I mean, we are IT people, we know that. So I try to never rely on anything that exists. That's why I bring everything along. No, but I will gladly give you access if you want.
At the beginning, I also tried to implement this MQTT, and that was not really straightforward for me. So I found really nice firmware called Device Hive, if you know about that.
What's it called, please?
Device Hive.
Device Hype.
Hive. It has already implemented HTTP server, so you can go directly to IP address. It has multicast DNS inside. It has a lot of features.
DNS, what's that?
Yeah, you can Google for that. It's really nice as a starting point.
Okay.
It's much nicer than working with MQTT brokers.
Okay, I'll have a look at it. I'm not quite sure what you mean by it's nicer than working with an MQTT broker, though.
The reason was because a lack probably of documentation. And I once installed MQTT broker, the Mosquito. That was not really straightforward to implement. So
okay.
the first thing that you can do is to buy these things.
It has man pages.
Yes, I know. The first thing that you have to do is to buy this device. Then you have to find out how to flash it. Find the correct firmware for that.
Yeah, hang on. But that is not Mosquito. Mosquito is a broker that you would install on your Linux box or on your
Yes.
mainframe or whatever.
So I want to advise to everybody to look into this project as Device Hive.
Thank you very much.
Hey,
James.
talk to me about the most complex thing you do today with MQTT at your house or work or whatever.
The most complex thing.
Yeah. The framework. The reason I asked is I'm still trying to understand the orchestration piece. You know, I use this, and I'm interested in how you do sort of, you know, message passing or build things using MQTT.
Okay, maybe the most complex thing, or the most, let's say, the thing that requires most getting used to in a lot of systems, particularly if you do things with HTTP. HTTP and MQTT are frequently compared, and this comparison basically sucks. It fails. HTTP is generally very high volume, so you have a lot of data because you have all the headers that are passed. HTTP is generally almost always a polling system. You have to poll for information. Those are some of the advantages of MQTT. But of course, some of the advantages of one of the advantages of HTTP is relatively trivial to do things like remote procedure calls. That is also relatively trivial, well, relatively easy to do with CoAP, which is also standardized protocol, also for the Internet of Things. It's a completely different view. Now, if you want to do anything that is sort of remote procedure call based, I want to send to a device, I want to ask it, how are you? You know, what's your battery level? I want to actively ask this. That is relatively hard to do because that is basically impossible to do with MQTT. So what you then do is the client who's interested in this information publishes a message, hoping that the client will pick it up, will use it, will do something with it, and then respond. That is, I would say, sort of the most complex thing to do because you have to wrap your head around topics and who gets what and who answers how. And yeah, I think that would be it. It is possible. We actually do. We have devices, tracking devices in vehicles, and we actually talk to these devices in the field over MQTT, over GSM networks. No? So I mean, this is really hardcore. If you can live with a system in which you basically ask a question and the answer can come back an hour later, then that's fine. If you need to immediately know, then you're probably using the totally wrong equipment, because then also GSM networks are the wrong way to do it. If the thing is offline because there is no reception, no GSM reception in that particular location, then you can't talk to it. Okay. So I think something remote procedure call like is probably the most complex thing to do. Did I answer your question?
One more question.
Okay, I will wait for you at the door for those gin tonics. And other than that, thank you very much for your attention. I hope it was interesting for you, and thank you.
Thank you, Jan-Piet.
Where's my son?